Hey there, and welcome to Raelene Math. I encourage you to pause the video and try to determine the equation of any tangent lines to the function y equals x squared plus x that pass through the point 2 comma negative 3. Now this is what I see a lot. I see people taking the derivative y prime equals 2x plus 1, and I really like the function notation f prime of x equals 2x plus 1, and then substituting 2 in for x and getting 5. And then writing the equation of the tangent line in point slope form as y minus negative 3 equals 5 times x minus 2. So now let's graph that line. Y minus negative 3 equals 5 times x minus 2 should be tangent to this curve, and doesn't look tangent at all. It looks like it's missing the graph completely. And so we have to figure out what went wrong here. When we took the derivative, we're assuming that the x-coordinate that we're dealing with is going to be the x-coordinate of the point of tangency. And that means that the point that we were given must lie on this curve. So if we were to substitute 2 in for the x-coordinate, we would get 2 squared plus 2 is going to be 4 plus 2, which is 6, which is not equal to negative 3. So it turns out that the point that we're given doesn't lie on the graph. So now that I know that the curve doesn't pass through the point, I have to rethink my strategy. I really want to come up with the equation of a tangent line. Y minus k is equal to m times x minus h. Sketching the picture is really helpful, and I know that y is equal to x squared plus x can be rewritten in factored form as x times x plus 1, which gives me my two x-intercepts at negative 1 or 0. And then I can find the midpoint of those two, which is at x equals negative a half, substitute that x-coordinate in to get the y-coordinate of the vertex. Another useful problem-solving strategy is to restate the problem in our own words, and so now I know that I need to solve for h, k, and m such that the parabola has a tangent that passes through the given point. And so I should draw the tangent because that's not on my picture yet. I do have the point plotted, which is good, and I have the parabola plotted. So I'm going to take the tangent as the line that the curve looks like when I zoom in far enough, and I want that tangent line to pass through the given point, negative or 2 comma negative 3. So I'm not exactly sure where my point of tangency is. That's what all this information is about, and I'm going to plot that point right around here, and I'm going to call it point A. So I have coordinates of that point at h comma k, and I'm going to put a third piece of information there to make the ordered pair turn into an ordered triple. The third piece of information is just the slope of the tangent line. Now, I like to give a name to that point. Since I'm using capital A, I'm going to use a lowercase a for the x-coordinate, which means that I'm solving for a, k, and m. But I actually have one equation, and my first equation is my function that says if I know my x-coordinate, I know my y-coordinate. So if my x-coordinate is called a, my y-coordinate is called a squared plus a. But I have a second automatic equation that I can get from derivatives, and I know that f prime of x is going to equal 2x plus 1. So right away, I can rewrite my first, second, and third numbers of the order triple in terms of only one variable. So I can upgrade my problem now to solve for a. I only have one unknown now because the two equations reduced two of the unknowns from 3 down to 1. I have the rest of the problem remaining though. So I notice that I haven't used the point 2 comma negative 3 yet, although I've used the function and I've created its derivative and used it. So probably I'll need to use this point. I think I'm going to give it a name of point B, and I'm going to take a look to see what the tangent line and point B present to me as information. I need some information that makes a truth, that makes an equation, so that I can solve for what's missing. And I notice here at point A that I have a tangent line, and that tangent line is a red line. And in fact, that red line is the same as the green line. And this is true. The red line is equivalent to the green line. Now that's not really helpful as an equation because a line isn't a single quantity. But if the two lines are the same, then I know that their slopes are. And the red line is the tangent line at point A, so I know that the slope at point A is equal to the slope of the secant line through the points A and B. And so now I can come up with this as my equation to work with to solve for my missing unknown. Specifically, my slope at point A is this 2a plus 1 expression. And so I'm going to get that 2a plus 1, if I write it down in a column, is equal to the secant slope. And recall that secant slope is just the regular old delta y over delta x. So here I'm going to get y2 minus y1, and just to be really clear, this is x and y over here like this. And so my y2, negative 3 minus y1, is actually not going to be as tidy as if I did y1 minus y2. So I'm going to write a squared plus a minus negative 3 all over x1 minus x2, which is x minus 2, except that it's not called x, it's called a. And so this is really nice because I have one equation, but that one equation has only one variable, and that variable is a. So now I can just solve the equation by clearing the fraction, expanding, and then simplifying the quadratic. So I'm going to pause the video, let you try that, and see what we come up with for solutions. Now since I have a quadratic equation for a, I get two solutions, and the two solutions, one occurs when x is negative 1, and the y-coordinate we saw was 0. We can work that out using the f of x function, x squared plus x. And we can also get the tangent slope by using the derivative, f prime of x, which is 2x plus 1. My x-coordinate is negative 1, and so when I substitute that in here, I get negative 2 plus 1, which is negative 1. So that's telling me that I get a tangent line that looks like this, and to write its equation, I can either use the point of tangency, which is negative 1 comma 1, or I could use the point that was given of 2 comma negative 3. Using any information that's given is easier, so the point slope form of that line looks like y minus negative 3, which is y plus 3, equals negative 1 for the slope times x minus 2. I could also write it using the other point, which is y minus 0 equals negative 1 for the slope times x minus negative 1. Both of those equations will give me the equation of the tangent line. So let's just take a look graphically and confirm that y plus 3 equals negative 1 times x minus 2, or even y minus 0 equals negative 1 times x plus 1 will give me the same tangent line. Just going to turn off that green, and the purple's underneath. And if I turn that one off and turn the purple on here, I see that both equations are fine. Now I see that this line passes through the given line, which is what I needed to happen, but I also needed the given tangent line to be tangent to the parabola. And if we recall what a tangent line is, it's what the blue graph looks like if we zoom in far enough. So if we zoom in at the point of tangency, we see that the blue curve is looking like the tangent line. And so I feel fairly confident visually that I've found the point of tangency and therefore the equation of the line. Okay, but I had another solution, so let's take a look at that. When x is equal to 5, I'm going to get another point of tangency. Now I can't actually see that on this graph. I've discovered that I don't really need the ordered pair here, I just needed the slope value because I can use the point 2 comma negative 3 to come up with a second tangent line equation. So the second equation would be y minus negative 3 equals some slope times x minus 2. And if I take the x-coordinate of the point of tangency and substitute it into the derivative formula, 2 times 5 plus 1 is 11. So let's take a look in another graph window to see if I can't confirm that. I'm not going to use this point, I'm going to use the one that gave me the given point and change the slope here to 11. It's a bit hard to see, so let's just change our window, and if I do that, I can start to see a point of tangency. So now this tangent line that I've sketched here in red does seem to pass through the given point, and if I find the point of tangency, if I can lock onto it and then zoom, if I have trouble locking on, I'm just going to type in the line x equals 5 and trace onto it from here. Then I'm going to zoom in and hopefully see that the red line and the blue curve look alike. And sure enough, it doesn't take long to zoom in when I can't tell the blue from the red anymore. Let me zoom out to show you. I've got a different blue curve from red curve, but when I zoom in they look the same. So I feel fairly confident that I found the equation of the tangent line, and in fact I have two tangent lines to this parabola passing through the point. If you like the geometric approach to solving this problem, click like, leave a comment down below, and subscribe to my channel. Thanks for checking out Raelene Math.